Okay, friends, we are going to use the data we have from my Wordle stats to figure out what the margin on that 94% is. We're making the assumption that that 94% is a good representative sample of all the Wordle games I have played and will play. Now, you already talked in the last question about why that might not be the most correct assumption. But in general, assuming you have drawn a random sample from a population and you have a sample proportion, whoa, exploding chalk, and you have a sample proportion, in this case of 94%, we're going to show you how to turn that and the sample size into a margin of error, which you can then turn into a confidence interval. All right. So first things first, let's start with the margin of error. Now this formula is going to look a little bit strange. I've dropped it with both my online and face-to-face classes. We've seen it in both places. It's got 4 components. The first is called the confidence multiplier. We're going to learn this throughout the course. Depending on when you're doing this exam, we may have already figured out what it is. That's the first part. Then there's a big square root. We're going to learn this later in the course. Under the square root it's effectively the standard deviation of a percentage. So in class and in the videos for the online folks, we're going to look at standard deviations calculated from continuous data. This is kind of a standard deviation from discrete data. We'll study it more in the binomial distribution, but the calculation for it is p hat times 1 minus p hat divided by n, which is the sample size. So this is the formula we have to use. The pieces of this formula we're going to get in here and there as we go through the course. But right now, effectively, you can think of this entire thing as the plus or minus margin of error, standard deviation, if you will, around that sample statistic. All we got to do is run numbers through it. So the z, for argument's sake, you can just call it 2. 2 is fine. It's technically 1.96, but at this point in the class, we're going to be calling that 2. That should be a little bit clearer. 2. No, it doesn't look too much like that z up top. Big square root. All right. P hat is the 0.94 times 1 minus p hat is 0.06. That's whatever's left. So 94% of the time I win, 6% of the time I lose. Again, the nitty-gritty of this is going to become more clear as we get into the binomial distribution later. We're going to divide that by the sample size, which is 142. All right, I'll be right back. Let me get what this is equal to. Okay, I'm back. I get 3.985%. I'm going to go ahead and call that 4%. If that's okay with y'all. That is so close to 4%, I'm going to call it 4%. Now, what does that mean? That means if that is my sample percentage, my sample proportion, p hat, I could be off by this much in either direction. So in other words, I shouldn't say Sean has a win percent of 94%. No. What we should say is Sean likely has a win percent between 90% and 98%. And I got that 90 and 98 by adding and subtracting 4% from that 94%. So that's how you end up calculating a margin of error for a percentage. Now you try.